Let's take a look at how we would write something that's in standard notation and turn it into something that's in scientific notation. Let's take, for example, the distance between the Earth and the Sun. And we say that's 150 million kilometers. Now, to write this as scientific notation, what we want to do is we want to write it as a mantissa. That's a number that is greater than or equal to 1, and that is smaller than 10. That's a mantissa, multiplied by 10 to the power of something. Now, the 10 to the power of something here, that's going to cancel out all these zeros. It's going to be a fancy and short way of writing all those zeros. And this here is going to cover what is going to cover this part. What is multiplied by all those zeros? So let's take 150 million. 150 million. So we want to write all these zeros in a short and easy way of 10 to the power of something. So let's say we have 15. We have 15, and we want to multiply it by something to get 150 million. So 15 times 10 to the power of 1 would be 150. And 15 times 10 to the power of 2 would be 1,500. Times 10 to the power of 3 would bring us here. Times 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7. So we can notice is 15 times 10 to the power of 7 is equal to 150 million. But this here isn't scientific notation because this here is not between 1 and 10. But we know that 15 is equal to 1.5 times 10 to the power of 1. So what we can do here is say, well, 15 is equal to 1.5 times 10 to the power of 1 multiplied by 10 to the power of 7, and that's equal to 150 million. So what we've just done is we've just replaced this 15 here by 1.5 times 10 to the power of 1. And here all we have to do is then combine it. So we can say 1.5 times 10 to the power of 1 times 10 to the power of 7 is equal to 1.5 times 10 to the power of 1 plus 7, so 10 to the power of 8. And this is scientific notation. So we say that human hair has a width of 0.00008 meters. Now here we can do exactly the same thing we did for the distance to the sun. We have 0.00008. So we want a mantissa that is going to be between 1 and 10. And we want something that is going to, we want to use a 10 to the power to cancel out all those zeros. So let's say we have 8 as our mantissa, 8. Multiplied by 10 to the power of negative 1, here 8, is going to be equal to 0.8. Multiplied by 10 to the power of negative 2 is going to be equal to negative 0.08. 10 to the power of negative 3, negative 4, and negative 5. So here we can say that 8 times 10 to the power of negative 5 is going to be equal to 0.00008. So let's find a short and easy way we can do it without always having to do those arrows. So for big numbers, so numbers that are greater than 0. So for numbers that are greater than 0. So for numbers that are greater than 0, such as 150 million, we can say that that's equal to, well, the first number here, so it'd be 1, number that's, so 1.5. Here we can use 1.5 because that's 115 is too big, so 1.5. And then we just knew it's the number of numbers till the end. So that's 1, 2, 3, 4, 5, 6, 7, 8. We can just count them. It's 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the power of 8. For numbers that are smaller than 0, it's the opposite. So we can use again our 0.00008. We just say it's, so we can use our mantissa, that's going to be 8. So 8 times, and we just have to do again numbers that would get us here. So it'd be 1, 2, 3, 4, 5. You always have to make sure you count the zeros. So it'd be this 0 here, this 0, 2, 3, 4, and then 5. You need to go to that original 0 that's before the dot, before the comma. So 8 times 10 to the power of negative 5. So that's a quick and easy way of doing it.